So this is an overview of the second iteration of the water level meter, and this is the capacitive version. So we have a big bottle of water here, and at the moment this is the water level sensor, and it's acting as a capacitor in the water, and it's just a piece of polypropylene pipe with two strips of tin foil taped to either side, and wires attached to each of the pieces of tin foil. And when that's in solution, that acts as a capacitor, and the capacitance varies according to the how much water is covering the tin foil plate. So here I'm moving it up and down, but of course in the water tanks the water level would be changing. The electronics for this are two parts. There's a resistive capacitive circuit that you can't really see very well, it's all a bit blurred, but the two resistors on the right hand side of the board are part of the resistive capacitive circuit. One of them is the resistor in the timing circuit, the other one is just the resistor that discharges the capacitor. We're measuring how long it takes for the capacitor to charge up to roughly 63% of its maximum voltage of 5 volts. And we know from the fixed resistance what the capacitance is. We're timing it over a second. We're timing it so that we can calculate after 63% what the capacitance is. That's one time unit. So the capacitance can be calculated, and the second part, where the Arduino comes in mostly, apart from doing the driving the resistive capacitive circuit, the Arduino is lighting one of 8 LEDs. So there's 2 red, which show our lowest level, 5 yellow, which are the bits in the middle, and 1 green, which shows us we're right up to the top. So if I dunk in the capacitor all the way, it doesn't always quite get to the green one. It depends, because it's a little bit wonky. But you can see it's got the 7th yellow light, the 7th light lit. So if I pull it out slowly, and it samples the level every 5 seconds, we can see that the light goes down. It should go down below halfway, or to halfway. Keep pulling this thing out. Now because it's a logarithmic calculation, it gets a little bit sensitive at the bottom, so the last couple of inches of this, there we go, and then it will tell me that there's no water covering it, which is correct. And you can see I've pulled the tube all the way out of the water. So if I put it back in again very slowly, you can see we're back up through the LEDs again. Now I like this version better than the reed switches because it's a direct physical measurement. It doesn't rely on any mechanical moving parts. So as long as the capacitance rod doesn't get damaged, or the wires don't come off, then this will keep working. I suspect when this goes into the real water tanks, I'm going to have to do some tuning, because I've basically just had to figure out what the maximum capacitance of this thing is, and then scale it in order to get the number of LEDs lit correctly. And that capacitance is obviously probably going to be very different for the big tanks, and for the capacitance rod for those is going to be 7 feet long. So I'm probably going to be dealing with quite a few more microfarads. This is actually up to, I think it's 100 microfarads in this water. And if you did the calculations, you could probably figure out, you know, why it was 100 microfarads, but I can't be bothered. It's just a useful number to know. So we're not going to get that that eighth light lit, because it's just being a little bit fussy at the moment. Let me see if I can do it. One last go. There we go. You just have to push it in a bit, and one of the wires is coming loose, which interferes with the capacitors. So there you go. The thing works.